can change from one element into another. But they don't do that spontaneously. It requires some nuclear reaction. And a nuclear reaction releases sometimes one of these three things that you see on the screen. You may release an alpha particle, which consists of 2 protons and 2 neutrons leaving the atom. That alpha particle contains a mass of 4 because it has 2 protons and 2 neutrons, and its atomic number is 2. So what is the alpha particle? Well, if the mass number is 4 and the atomic number is 2, what element has 2 as its atomic number? Should see that it's helium. So what I'm saying here is if an atom releases an alpha particle from its nucleus, whatever element it was is now reduced by 2. So if you have an element, for example, thorium-230, and it undergoes the release of an alpha particle, what atom does it become? Well, what's 90 minus 2? It's 88. And if you look on the periodic table, 88 is the symbol or the atomic number for radium. What's the new mass of radium? Started out at 230, lost 4, so it's 226. This right here is the alpha particle. If an atom loses the alpha particle, it loses a mass of 4 and the atomic number of 2, which also happens to be a helium atom. Another thing that can happen during nuclear reaction is the release of a beta particle. When a neutron has no atomic number, but it has a mass of 1, can split into a proton and an electron. The proton has an atomic number of 1 and a mass of 1. An electron has no mass and a charge of -1. So does this add up to my neutron? 1 plus 0 equals 1. 1 minus 1 equals 0. So yes. So this is my neutron, this is my proton, and this is my beta particle. An atom may lose a beta particle. For example, tin-121. Tin is 51. Releases a beta particle. So I release this beta particle from my atom. That means that I have essentially gained a proton in my new atom, but not lost any mass. So my mass number stays the same at 121, but this number goes up by 1, and I become element 52, which is Te, or tellurium. Okay? So in this one and this one, I actually have a particle. Some radioactive reactions release a lot of energy, and that energy is often referred to as a gamma ray. Okay, it's not an actual particle, but it is a lot of energy. And gamma has the symbol that looks like this. So you've got alpha that's a little like a fish, a beta that's a B with a negative, and gamma, which is a Greek symbol, that looks like that. Remember, not all isotopes are radioactive. When an isotope goes through a nuclear reaction, the reason why is because in the nucleus, there's not enough glue or atomic attraction to hold those particles together, and they are released, okay? And it breaks it down until it becomes stable, okay? Uranium is talked a lot about in the news, or it was not too long ago. Uranium-238 is a radioactive element, radioactive isotope of uranium. It will go through a variety of alpha and beta reactions until it becomes stable. And when it's stable, it is the element lead. Okay, so remember when we went through the slide before, when it undergoes an alpha reaction, it loses 2 protons. When it's a beta reaction, it essentially gains a proton. So it goes back and forth, until eventually uranium-238 is stable, but is now, instead of uranium, is the element